After we look into the constructor, empty, and traverse function of the linked list, you should have a basic understanding of how linked list is working. Now, let's take a look of probably the most complicated operation in the linked list, which is the insert operation, to see how can we put the items or construct a new linked list through the insert function. So, to insert a new data value into a linked list, we must do the following two things. First of all, ask the operating system find a available location for us, so that we have a location, we have a space to store the data part and the next part. And then we're going to put the value, which is the elements that we want to store into the linked list into the data part. That is like the preparation of the linked list insert operation. Then, depending on what's the scenario, actually what is the insert location that you want to do, then we try to put this item into the linked list. There are two scenarios. The first one is the general scenario, indicating I want to insert the items after some point, some elements in the list, which means that you want to insert the new item in the middle of the linked list. That's the general scenario. The special scenario is that you want to insert the item into the beginning of the list. We will look the general case first, and then we will dive into the special case here. So let's take a look of the general scenarios. In the example that we provided over here, indicating that we have 5 items in our linked list. The first pointer indicating where is the beginning of the linked list. So this linked list has 5 items starting from 9, 17, 22, 26, and 34. Saying that we want to insert a new item that's the value of 20 at the location after the second item, which means that this would be on the third item. So you can see that to do an insert operation, you have to provide 2 parameters. First parameter indicating what's the value that you want to do the insert. The second parameter indicating that where you want to insert this item. So you can see that in this case, we are doing the insert of 20 and 2, indicating I want to insert the item of 20 after the second location. To do this, first of all, we need to get a new space. So operating system will need to reserve a new space for us, and then we will need to remember what is that address. So we need to create a pointer variable to store the address of this new item. Saying that we name this pointer as new PTR, indicating where is the new location that operating system reserved for us for the insert operation. Then we need to put 20 because that's the value that we want to do insert operation. So we need to put 20 into the data part. So that is like what I mentioned earlier, the first step of the insert operation. Then we need to link this one properly into the linked list. Since we want to put this one after the second item, we need to find the second item first, which is the item before the new elements want to be inserted. So that what we're going to do is that we need to go from the beginning, find the item, the second item, and then use another pointer to help us point it at that location. So you can see that why I say insert operation is a little bit more complicated, because in this picture you can see there are actually 3 pointers. You need to understand what are those pointers for. The first pointer or the top pointer indicating where's the beginning. So that is the place that we never want to change. We have a new pointer point at the new space that we have been created. And we need a pre-PTR starting from the top or the first pointer points at, walk through until the elements that we want to insert the new item front. So that is what the pre-PTR trying to do. So once we have all of these three things ready, we are ready to make the link. Because you can see that for the new PTR, this next part need to point at the address of the item 22. And where is the address of the item 22? It's actually the pre-PTR's next part. Point at that address. So what you need to do is make new PTR next over here, point at that address, so that we can properly link the new item to the next item. And then we need to change pre-PTR next, which is this address originally pointed at address of 22 element. We now need to point at new PTR address, so that what we will be able to do is that we will be able to link the first goes to the element of 9, look into element of 17, look at the element of 20, now 22, 26, and 34, so that we will be able to properly link all of them together. That is the idea of the insert operation. This whole process also works if we want to insert the item at the end of it. It's nothing, everything stays the same piece of the code. The special case is that if you want to insert the elements in the beginning of the list, and we do have a separate code as well as examples to see this one. No matter what, you can see that there is no shifting of the element. You don't need to move elements from one location to another location. All you need to do is go through the process of searching the element until you find the items that you want to insert front of it. And then we will be able to create the linked list properly. Now, let's take a look of the code. This is again the code for the general case. So that let's try to look this line by line and try to understand what is this code trying to do. For the insert operation, like I mentioned, it takes two parameters. One is the element, which is the value that you want to insert, and the position, indicating what is the elements that you want to insert after. Now, take a look of these two lines. This two lines is the preparation of the code. What it will do is, first of all, new node, indicating that operating system, go fetch a location for me to store the node data type, which is the one that we created. It has the data part and the next part. So when operating system see new node, it will go into the memory, find a new location and hold it for us to do the operation. Now you can see in front of it, we want to create a pointer in the data type of node. So start over here, indicating I want a pointer, point at that new location. So you have a new pointer, point at a new location that it has been created. Next, this location, so new PTR to the data part. Again, remember we mentioned this is the sign to indicating that which part of the new pointer points at I want to access. When we do new PTR, this arrow sign, data part, indicating I want to access the data part. And then we make element, which is the value we want to insert, store that into the new PTR to the data part. So this time we have done the very first part, prepare the space, and then put the element into the data part. After that, we need to find a way to walk through until we find the front element of the element we want to insert. So we starting create a pre-PTR, and then make pre-PTR equals to top. So we prepare the pointers for us. Since we don't want to move top at all, we use this new pointer we created called pre-PTR equals to top at the beginning of that. And then, just like the traverse operation, we need to walk through items one by one until we see it stops at the position -1, that indicating that is the pre-PTR supposed to be, and the new element we want to insert is after this pre-PTR location. So when we go do that, we have pre-PTR equal to pre-PTR next, which can give us the location of the movement, and we will be able to move to that location. Once we find it, that gives us, like I said, we have new PTR, we have pre-PTR, and the top will always stay at top. We have all 3 pointers available. Then we try to make new PTR to the next part equals to pre-PTR to the next, which is corresponding to this step. So we will link this one, and then we will make this connection, pre-PTR next equal to new PTR. So you see pre-PTR next equal to new PTR. So that this 2 line is the key to make all connections successful. And of course, all of these steps are the preparation for this 2 line of the code. Of course, we need some example to fully understand this. Let's take a look at this one. So saying that we have this example, and again, I have made the code available on the left side, and we will be able to look into the examples that I developed. Saying that this is a current linked list that we have. So there are 4 elements. And in order to make you be able to see the address kind of ideas, we created a simplified memory space again. And then in the beginning, this linked list starting at the top equals to address of A, indicating that this is the very first item 9, just like this way. Now, the next item stores at the address of 2. So this 17 is the next item. Next item is 22, next item is 34, and that's the end of it. So this is the memory space looks like to represent the linked list that we have over here. Saying that we want to insert the value of 26 after at the 3rd element. So basically what we want to do is that we want to insert the new value after the 3rd occasion. 1, 2, 3. So we want to insert a new element over here. And therefore, this is like our goal. We want to be able to successfully insert the element of 26 in this spot. So how do we do that? Let's take a look at the step-by-step operation. First of all, we need to make the new node. So this is the first part. The new node operating system will go into the memory space, finding an available space. Saying that it randomly select the address of 6. Of course, this can be any other locations. Saying that we reserve this location, now we need to make new PTR. So we need to remember that address. So we have the new PTR equals to the new location that we just created. We need this pointer to remember where is that being pointed at. Next one, we put the data part into the data part element into the data part of the new PTR to the data. And then what we're going to do is that we now prepare the pre-PTR. So we create a pre-PTR equals to top at this location, and it is time for us to look into the loop so that we will be able to walk through the items and then make the pre-PTR stop at the 3rd item. So how do we do that? In the loop over here, remember the position is 3 that we provided. So let's take a look of the code. Starting I equal to 0, which is here, pre-PTR equals to pre-PTR next. So you can see that we make the pre-PTR equals to pre-PTR's next. So now the next part is 2, indicating the next item is going to be stored at the address of 2. What we will do is that we will put 2 into the pre-PTR. So pre-PTR will move to the address of the 2. Let's take a look at that. So you see that when we do that, pre-PTR is at the address of 2, which is at the 2nd items now. And then what we're going to do is that we need to go back to the loop. I now change to 1. 1 is still less than position minus 1, which is 2. So we need to keep moving. So we will continue this line of the code over here, make pre-PTR equal to pre-PTR to the next, which is equal to 7. So now once that is done, we will look into this location. At that time, I will go back over here, increment by 1. It is the stopping point, which is the pre-PTR at the 3rd item over here. So when that is done, we have our preparations done. So what we need to do is simply go into this line of the code, make pre-PTR next equals pre-PTR next, new PTR next equal to pre-PTR next. So you can see that new PTR next is this spot equals to pre-PTR next. So we put this 0 over here, and then we're going to put the pre-PTR next, which is this one, equals to the new PTR, which is 6 over here.